सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Radioactive Community Radio, Bengaluru.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
Latest information on STEM popularization.
TDB DST backs Mrs. Lekha Wireless Solutions, Bengaluru in advancing India's wireless communication technology. Prime Minister Shri Narendra Modi has aptly stated that India's progress hinges on our ability to embrace technology and innovation. These words resound with the Government of India's dynamic initiatives in the field of wireless communication technology. These endeavors encompass a multifaceted approach, including the promotion of research and development in emerging wireless technologies, the encouragement of domestic production of wireless communication equipment, and the facilitation of the adoption of cutting-edge wireless solutions across crucial sectors, including defense, healthcare, and telecommunications. This robust commitment exemplifies India's dedication to advancing technology and attaining self-reliance in the realm of wireless communication, making significant contribution to the nation's prosperity and security. Building upon this vision, the Technology Development Board has announced its support for Mrs. Lekha Wireless Solutions Private Limited, Bengaluru, for their innovative project Tactical Advanced SDR for space defense and aviation applications. This agreement shows a significant stride towards promoting innovation and technological advancement in India. Particularly in the realm of wireless communication, TDB has approved financial assistance of Rs 4.17 crore out of 17.92 crores. This ambitious initiative holds greatest potentials for strengthening India's capabilities in the field of wireless communication technology. The project's primary aim is to bring to the market an array of cutting-edge products under the brand name Antares. These products encompass handheld SDR, multi-channel SDR, SATCOM SDR, high-power add-on. Researchers have synthesized highly crystalline pyrite FES at low temperature and utilize them for fabricating electrochemical energy storage devices such as batteries and high energy density supercapacitors. Transition metal sulfides are an important class of inorganic materials and they find application in diverse fields including electrochemical energy storage devices such as batteries and supercapacitors. Solid-state synthetic methods are used to generate metal sulfides from the corresponding metal salts or their equivalent oxides, usually by annealing at high temperatures. However, the experiments carried out by Ms. Savitri Vishwanathan under the supervision of Dr. H.S.S. Ramakrishna Mate at Center for Nano and Soft Matter Sciences, Bengaluru, an autonomous institute under Department of Science and Technology, demonstrated the low temperature synthesis of crystalline pyrite FES. through a solid-state synthesis route. They have utilized a metastable oxyhydroxide precursor for this process. The team reported stabilizing this intermediate oxyhydroxide and utilizing it as a precursor for sulfidation in the presence of H2S gas for the first time in the paper published in journal Chemicals Communication. Using a metastable precursor helping in lowering the annealing temperature as FeOOH converted into pyrite FeS2 with fairly good crystallinity at a low temperature. This synthetic route of obtaining sulfides from their corresponding metastable oxyhydrides can be extended to other transition metals to obtain crystalline materials in an energy-intensive.
Now, our next segment is Analyst in STEM.
Today we are with Dr. Bivas Saha, Associate Professor, International Center for Materials Science, Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru.
I'm Bivas Saha. I'm an Associate Professor at the International Center for Materials Science as well as in the Chemistry and Physics Unit of Jawaharlal Nehru Center for Advanced Scientific Research. We are a research group in ICMS JNCASR comprising of around 12 to 13 PhD student, postdoctoral scholar, research students. And we work on heterogeneous integration of materials, looking at the various properties of materials and their applications in electronic and optoelectronic devices.
Could you please brief about the area of research that you're currently working on?
Sure. So we work on heterogeneous materials, we work on heterostructures. Basically, we work primarily on semiconductor heterostructure, trying to make them more efficient in terms of their electronic and optoelectronic applications. We also work on semiconductor-based neuromorphic devices, trying to emulate functionalities of brain in computing devices. At the same time, we have a program on optical properties of various nanostructures, and these are directed towards their applications for harvesting solar energy or renewable energy wherever there is a possibility to convert them in useful technologies.
Okay. So could you add on about any examples of your research discussion?
Sure. So I would love to discuss about our work on neuromorphic computing. So this is the work that we are doing, trying to replace our existing computer architecture. We know in existing computer systems they are too much power hungry because they work on an analog or they work in a digital 0 and 1 system. Whereas our human brain works in a completely analog way. It performs much more functionalities in a much less power. So you can consider that our human brain daily operates at 20 or 30 watt, whereas some of the most advanced supercomputers take megawatt of power. Yet they are not as a fraction of efficient as our human brain is. So one of our project is trying to emulate the functionalities of brain to build computers. So in this case, we develop semiconductor heterostructure. So we make some of the most cleanest of semiconductor heterostructure that are there present because we really have to control the electronic transport, lattice vibrational transport or phonon transport, and then we can make this brain inspired or neuromorphic computing devices which emulates the functionalities of brain in an electronic devices. So that's one of our current research goal that we are presently pushing because there is a lot of not just industrial application but also a lot of strategic and security applications also for our country as well as for society.
Okay. So how is your research beneficial to a common man or India as a whole, and what kind of contribution is it making to the field of science in India?
Right. So our research is more on the applied side or applied physics research. So pretty much everything that we do is directed for a certain application. So we work on semiconductor heterostructure, but one of the application, as I just described, is in neuromorphic computing. So should we succeed, and when we succeed, we will be able to make semiconductor devices, and we'll be able to make computers which will work at a much lower energy consumption, benefiting the entire country and entire society. At the same time, as we know, there is a huge issue about energy consumption in buildings, energy consumption for cooling devices, so on and so forth. So many of our research are actually addressed in creating technologies which reduces the energy consumption in this. So our research, as I was mentioning, is mostly on taking concepts of physics, fundamental knowledge of physics, material science, chemistry and electrical engineering, and really to make to apply them in practical devices for real life applications.
Okay. So, could you share more about your past, present, and future area of research?
Yeah, so I'm an associate professor. So before that, I did my PhD and postdoc from USA, Purdue University and University of California, Berkeley, where I used to work on similar version of the research topics that I work today. I used to work on heterostructure and thin films and transistors when I was a PhD student and postdoc. And after I started here about 5 years back at JNCASR, we have continued in some sense on some of the topics that I've worked before. Neuromorphic computing devices, energy system, trying to make efficient energy converter, heat to electricity energy converter, and in the foreseeable future, we tend to make we will continue working on the current projects that we're working on, but also at the same time we'll be looking forward to work on newer areas in terms of critical technologies, both that will be most relevant for our country and also for the society.
So, what are the hardships that you face in accordance with?
I am an experimental applied physicist or engineers, and the nature of our work unfortunately requires a lot of resources. Okay. These resources are not only financial, of course there is a large part of it which are financial, but these resources also are sometimes intellectual. There is a very less critical amount of people who are working currently, at least in Bangalore or in India, on some of the most advanced topics that we are working in. So we not only have to find funds to make to buy instruments which are cutting edge or to make systems which are at the cutting edge. We also have to always collaborate with like-minded and our peers working in the same field. Sometimes they are not always in India, so we have to talk to them. So in terms of hardships, describe it as a hardship, but it's a constant challenge to find this balance between what we can do with our existing facilities, existing funding, and what really advanced solution of the advanced problems require you to devote in terms of your time and resources.
So, do you have any idea about where India is right now ranked at in your field of research?
Well, I would have been much happy if I would have said India is at a very high position. Unfortunately, it's not, but we are making significant progress. In fact, over the last 3 to 4, 5 years since I'm here, I do see a lot of energy and effort in this direction. I would still say that perhaps some other countries like US or China or Europe are ahead than us, but we are trying to constantly bridge the gap, and as I mentioned, in recent years there have been efforts. I would love to see government, private industries come together more on this sort of aspects, more research and project being funded, people look for realistic solutions of existing challenges, and there is a lot of, and that, and in some sense it's good actually, because that gives you a lot of room for growth and innovation and movement. So yeah, I mean, I'm optimistic, but at the same time we need to go a lot. So the topics that I currently work on, as I said, I did my PhD in Purdue and I had my background in US. So of course my own professors or teachers, many of them are working at US in some of the best universities. In India also there are a few places where there are some advanced cutting edge technology research that we are working on currently goes on. Of course, one of the example is Indian Institute of Science. I have some friends who are working on similar things, not exactly same things, but similar, and which are also very fascinating and interesting. There are some people working on at Tata Institute of Fundamental Research at Mumbai, IIT Mumbai and IIT Kharagpur also. So Yeah, I mean, I think by and large, this is pretty much the places where most of the work that I work on is going on.
Okay. Has there been any working model developed which has created an impact in the society?
Yeah, I'm so happy to share. I'll just give you one example.
Yeah.
One of the major problem of our time is heating, right?
Yeah.
So in Bangalore, you may not see that quite much because we are in a much pleasant weather.
Yeah.
But you can think of in North India, if you go, buildings, roofs in summer, they really heat up extremely hot.
Exactly.
In fact, temperature reaches 40-45 degrees C, but if you touch a building, touch a surface, their temperature is at least 10 or 15 degrees higher than that temperature. If you go to temple, you don't want to open your shoes and touch the feet on the floor because that's just so hot. So just 2 years back, we were approached by a company to develop coatings for buildings which will cool the surface of buildings at least say 10, 20, 30 degrees C below the temperature where it is. And this has to be done absolutely passive way. You cannot just attach an electrical current and then you can draw this from with AC or things like that.
Okay.
You cannot put an AC on building, right? I mean,
Yeah,
outside of the
certainly.
building, not inside of the building I'm talking about. So we have managed to develop the coating. It turns out that it is much easier solution, but it required some innovative work where we have made a radiative cooling paint which if you paint it on any surfaces, it cools the temperature 15 degrees C than the ambient temperature.
Okay.
So think about this, you go to a temple, you touch a floor and it's so hot you just don't want to put your feet. But now if you put our paint, you will touch a surface which has 10 to 15 degree C lower in temperature. So this is the most real life experiments or product development that we have done over the last 2 years, which we are quite excited about.
So how are Indian industries associating with your research project?
Yeah, that's a very nice question. So we work on advanced heterostructure and solid state devices. So when we talk about industry that does this sort of work, we are talking about, for example, say Intel, we are talking about Global Foundries, we are talking about Micron. So these are basically semiconductor chip processing company or light emitting diode company, so on and so forth. So some of them are India, but most of them are India to sell the products. Okay. They have their offices, but they have their offices to sell for regional sales offices. Unfortunately, they don't have the R&D team in India. Most of their R&D are in US, some are in Europe. So one of the challenges has always been that you can always tie up with them, but if they don't have any fabs in India, if they don't do research and development in India, then how you take ideas forward? They are here only for business, and right, and they have their own reasons to do business. There's nothing wrong in it. So I think, but this. What at least my hope is that with coming years, with government incentives, they will make more research R&D centers in Bangalore or in India. There are more fabrication facilities in India. So that will not only help us trying to find a very good interface with the industry, the sort of problem that they are dealing with and the sort of science we are doing here, but it will also help us students to get us good quality, high-paying jobs for their own future growth. So that's actually extremely important. It's heavily lacking in India, at least in my own field of research, and I would love to see that.
Here we are, signing off. Stay tuned with us to catch up on the latest science updates and learn about STEM experts.